demos from all the previous speakers. I'm Shubham, a research scientist at Avataar. Uh, at Avataar, we are democratizing and enabling spatial storytelling. So the first question you'll have is, what is spatial storytelling? And I think it's better shown than explained in words. So I will present some examples of spatial stories that e-commerce businesses might narrate to their customers. And stories like these can be created by our experience creator that just happened to be released today. So here we go. All right, so spatial storytelling exploits spatial depth. It basically uses 3D assets to create a smooth and seamless storytelling experience. It's a far more engaging form of stories that evokes a stronger physical connect than just images or videos. For example, this is a story about an ergonomic chair that beautifully combines a visual inspection of different parts of the chair with utilitarian information showing different settings of those parts. It feels like the information is a part of the chair itself. Overall, this leads to an aspirational emotional connect with the product. In some cases, spatial stories can actually surpass an in-store physical experience. Here is the example of an Omega watch. In this spatial story, you'll see a blowout of the watch showing the gears and the inner workings of the watch. And this is simply not possible in a physical store. All right, so the question is, how can generative AI enable such spatial storytelling? And that's what we're doing at Avataar. We've seen a boom in GenAI for different modalities. Most of what we discussed today earlier has been based on text, but there's also images and videos, although that's still in the early stages. At Avataar, we are tackling 3D generative AI, which will have an enormous impact and enable spatial storytelling. 3D generative AI models can act as a 3D co-pilot, making artists superhuman and allowing them to focus on creative aspects of their work. As 3D asset generation becomes more convenient, so does spatial storytelling. Game development, which is often bottlenecked by 3D content generation, will also get easier. And there are other areas which will be impacted by 3D Gen AI, like machine perception and robotics. Technically, 3D also has a bunch of benefits. Rendering 3D assets is highly controllable and efficient, and you also get temporal consistency for free, which is something that video generative models struggle with. Notably, the generated 3D assets can be reused in different stories by being rendered differently. So to set an overall context, there's a growing list of unit problems that need to come together for the later product market fit that we see across the 3D industry. I've cherry-picked some of the most important and interesting directions to draw analogies for a discussion today, and I'll talk about them one by one. First and foremost, real-world 3D data cannot be captured naturally. That is because parts of objects will always be hidden from view, or they'll be occluded, or you can't see the internals of things. For instance, you can't see what's behind a sofa till you move the sofa, or see what's inside a watch without dismantling it. As a result, the available 3D data available on the internet is much smaller and artist generated. Here's a plot that shows it. So on the left, you have Lion 5D, which is the largest image data set that's publicly available with 5 billion image text pairs. And on the right, you have Observerse XL, which is the largest available 3D data set, which just has 10 million 3D assets. That too synthetic. So you can't just use 3D data to build generative models for 3D. What you need to do is exploit large image and video data sets in addition to the small 3D data that's available. We're doing this at Avataar, and here's a sneak peek, where we lift single 2D input images, as shown on the bottom, to full 3D assets that you see on the top. This is fully automated, and we achieve this using GenAI models trained on diverse data sources like I just discussed. Another aspect of 3D generative AI is editability. A monolithic 3D asset is rarely any use. Any artist or creator would typically want to edit whatever asset is generated, either by fixing the geometry, changing the texture, or segmenting to have different parts to achieve a blowout effect like this. We don't need just easily editable assets. What we want is generative AI to actively assist in the editing process itself. We need generative models that can interactively segment, in-paint, refine, and modify different parts of the assets as per user needs. Context also becomes very important in spatial storytelling. So here's an example of a dishwasher. Standalone, the dishwasher doesn't feel very aspirational, but what a storyteller might want to do is show it inside someone's home to give an idea of what it could be like. So you might want to position the dishwasher against the wall, under the shelf and beside a cabinet, and in doing so, generate the rest of the 3D scene that this dishwasher should be placed into. So we need 3D generative models that are able to generate the rest of the scene given the dishwasher as context. So we need incremental scene generation. Now, 3D editability and context generation, these are problems that we are also working on at Avataar to reduce the tedious effort that artists undertake to do these problems. Efficiency is also a very big part of the generative AI experience. It doesn't just affect costs, but it also very severely affects usability. We need efficiency in both 3D generation and rendering, ideally making them both real time. Generation because you don't want to sit for an hour waiting for the result, and rendering because a high quality asset is no use in a story if you can't render it photorealistically in real time. To summarize, I've shown you what spatial stories look like and discussed a bunch of problems that we are solving at Avataar to enable spatial storytelling using generative AI. Thank you so much.